Today we are talking about metamorphic rocks. And metamorphic rocks form through a metamorphism. That word just simply means to change. It's a word you've probably heard a long time ago, like in kindergarten, when you watch that cute little caterpillar turn into a butterfly. When it comes to metamorphism with rocks, there's two key elements, heat and pressure. You need to have heat and pressure to cause rocks to change, but we're going to get to that more later. Just like we had with the other rock groups, there are categories of metamorphic rocks. The first category of metamorphic rock is contact metamorphic rocks. Contact metamorphism happens when a rock is in direct contact with a source of heat like magma. It almost like cooks or burns that rock layer. Something that's going to be really important to remember for each of these different categories of metamorphic rocks is how much heat and how much pressure. Again, those are the two key elements that cause changes within a rock. So in terms of heat and pressure for contact metamorphism, there's really high heat, we're touching lava, but there's very low pressure. The second type of metamorphic rocks are regional metamorphic rocks. And regional metamorphic rocks are usually formed through mountain building events. So something like the Himalayas right now. The Himalayas, that entire area, massive area, is undergoing a mountain building event. When we have India colliding with Asia, crumpling up all of that continental crust, there's going to be a whole lot of pressure, and that causes a great amount of heat. So in terms of heat and pressure and regional metamorphism, there's very high heat and very high pressure. That's why regional metamorphism has the greatest impact on rock layers. It makes the most amount of change. And we call that a high-grade metamorphism. Also, since we're talking about a large land area that's being metamorphosed all at the same time, regional metamorphic rocks are the most common type of metamorphic rock, just because the quantity of rocks changed all at one time. The third type of metamorphism is burial metamorphism. And this is when rock layers just simply get buried under tons and tons of sediment and additional rock layers. In terms of heat and pressure, it's going to be very low heat. But pressure is very high. The weight of all of those layers takes its toll and causes a metamorphism. The next part of our notes talks about what they call the agents of metamorphism. It's really the factors, the variables that can make a change to rocks. And one of those is obviously heat. Heat and pressure are the main two. And heat can come from just the depth inside the earth, or it could come from pressure. Heat is probably the most important part to metamorphism, just because heat really drives chemical reactions. The second variable is pressure, and pressure tends to flatten and elongate minerals. Kind of like if you have a ball of Play-Doh that you squish. It flattens the Play-Doh and it stretches it out to the side. That's what we're talking about. It also is the factor that makes minerals bend without breaking. Rock layers can bend without breaking, and that's something we're going to see in just a little bit. The last variable that can cause a change, can cause a metamorphism, is just a hydrothermal solution, a reaction in a solution. And what happens here is you take an already existing rock and you pass some hot water by that rock or through that rock. And what that hot water does, that hydrothermal solution, it ends up dissolving away elements from that rock. And it removes them completely. So now the chemistry of that rock has changed, and a metamorphism really just means to change. So even though we're just removing certain elements from that rock, we now have a different rock, so we've caused a metamorphism. When it comes to classifying metamorphic rocks, there's really only two categories of classification. There's either going to be foliated metamorphic rocks or non-foliated. Foliated metamorphic rocks are ones that have color bands or very distinct layering. And this happens because the parent rock, what it was before the heat and pressure, had multiple different types of minerals. So when there's heat and pressure applied to a rock, those minerals, they can actually separate and they produce these bands, these distinct layers. Non-foliated metamorphic rocks, they don't have any color banding or any layering, and that's because the parent rock was just made out of one material, one thing. Like the metamorphic rock quartzite was made from sandstone, and sandstone really is only made out of one mineral, quartz. So those individual pieces of sand that were in the sandstone, they just warmed up, they heated up, they became kind of squishy, And with the pressure, those individual sand grains ended up interlocking and forming quartzite. There are just a small handful of metamorphic rocks that you're going to have to know for the test. And these rocks can be seen, let's say if you were driving through a metamorphic mountain range. And they go from very low grade or small changes to very high grade or lots of change in a rock. If you start at the base of a metamorphic mountain and you start driving up, you're first going to see slate. Very low grade metamorphism, not a lot of heat and pressure, a very small change has taken place. As you drive up, you're going to pass through phyllite, which is a higher grade metamorphic rock, and then to schist, and finally in the middle of the mountain, the top of the mountain, you're going to find gneiss, which is the highest grade, the greatest change, the greatest metamorphism that has happened to rocks. Then as you drive down the mountain on the other side, you're going to see those same rocks just in reverse, from gneiss at the very top to schist and phyllite and slate. That's all we have for metamorphic rocks. Please make sure you're going to ask questions and make sure you're taking some good notes. Thanks.